So today we are going to discuss about properties of whole numbers. The first property is that closure property. Whole numbers are closed under addition and under multiplication. So now how we will discuss that one. So if I write 7 plus 8 is equal to 15. There you can see 7 and 8 both are whole number, and the result 15, that is also whole number. So if I take any number 5 and again 4, and the result will come 9. So here 5 is a whole number and 4 is also a whole number and 9 is also a whole number. So we can say that if we add whole number with whole number, then the result will come whole number always. So what do you mean by whole numbers? We know that from 0, 1, 2, 3, 4 and so on. So all numbers are whole number. So whole numbers will start from 0, and we know that natural number will start from 1. 1, 2, 3, 4 and so on. So now we are discussing about properties of whole number, and under that first property, that is closure property. So I have discussed already, whole numbers are closed under addition and multiplication. So that is addition. If we plus whole number with another whole number, then the result will come whole number always. And same thing if we do for multiplication, like 5 into 2, that is 10. So 5 is a whole number, 2 is a whole number and 10 is also a whole number. But one more thing, that is whole numbers are not closed under subtraction and divisions. So whole numbers are only closed under addition and multiplications. One special note for 0, that is division of a whole number by 0 is not defined. We have to remember that one. Now I am going to discuss about commutativity of addition and multiplication. So under this property, we can find out we can add two whole numbers in any order. Like that, if I write 4 plus 6 is equal to 6 plus 4, I can write. In both cases, same answer will come. 4 plus 6, that is 10, and 6 plus 4, that is also 10. So we can say that we can add two whole numbers in any order. Same way, we can multiply two whole numbers in any order. If I take same example, 4 into 6 is equal to 6 into 4. 4 into 6 will come 24. And 6 into 4 will come 24 again. So we can say that we can multiply two whole numbers in any order. So that is our second property, commutativity of addition and multiplication. Thus, addition and multiplication are commutative for whole numbers. Addition and multiplication. Remember, only addition and multiplication are commutative for whole numbers. If we say subtraction and division, that are not come under this commutative property. So we have done closure property, we have done commutative property. Now we are going to discuss about associativity of addition and multiplication. So I am taking one example, that is 2 plus 3 plus 4. So 2 plus 3, that is 5. Then plus 4 is equal to 9. Now I am doing another way. 2 plus 3 plus 4. Now 3 plus 4 within bracket is equal to 2 plus 7 is equal to 9. Are not the results same? Yes, same. Here I have applied two way, but the results will come same. So under this property, associativity of addition and multiplication, we have to find out there is only one function, that is the function of brackets. So we have to find out which one is easy for us. If we write 2 plus 3 plus 4 and we give brackets, we write 2 plus 3 within bracket, and if we write 2 plus 3 plus 4 and we write 3 plus 4 within bracket, in both the case answer will come same. So under this property we have to find out which one is easy for us. So I am taking one more example to explain that one. I have written three numbers here, 243, 197, 103. So now I am going to add the numbers. So 243 plus 197 plus 103. So now I am applying associativity of addition. Now I am applying associativity of addition. Now how? 243 plus 197 plus 103. Here we can see if I add 197 and 103, then I will get a good result, that is 243 plus 97 plus 3, we know that 100, so easily we can add them. So 97 plus 300, and there is 100 and 100, so 100 100 200 and one more 100, so that is 300. So now easily we can add them. 300 plus 243, that is 543. Clear? 543. So that is our answer. So we can apply associativity of addition with these brackets, and we can do this addition easily. So that is the function of associativity of addition. Same thing we can apply for the multiplication also. Now I am giving one example that is regarding the multiplication. That means associativity of multiplication. So first example is that 6 into 5 into 3. So first I have given bracket here. So I am doing that one. 6 5s are 30 into 3. 33 is a 3 3s are 9, 90. Clear? So same thing I am doing here, but here brackets are changed. So 6 into 5 into 3, same number, but now I have given bracket here. So I will do that one first. 6 into 5 into 3, that is 15, and now I have to know the 15's table, then only I can do this one. So 15 into 6, that is 90 again. So which one is easier for us, first one or the second one? That is, I have applied associativity of multiplication. Now I have done first process and I have done the second process. Now easily we can identify this is the simpler process, so we can apply this one. I am taking one more example, that is 9 into 4 into 25. Same number I am writing here, 9 into 24, sorry, only 4 into 25. So now I am giving bracket 9 into 4, and here I am giving bracket 4 into 25. So if I do this one first, then 9 4s are 36 into 25, and if I do this one, then 9 into I have to write, and then 4 into 25, that is 100. So now I have to do that multiplication, then only I can identify which is our answer. So that is big multiplication, 2 digit into 2 digit. So 36 into 25. Obviously if we do here, then the answer will come 900. 36 into 25, 5 6 are 30, 0 3 carry, 5 3 are 15 plus 3 18, 2 6 are 8 12 carry 1, 3 2 are 6 plus 1 7, then 0 8 2 0 carry 1, 7 plus 1 8 plus 1 9, 900. Clear? So that 2 digit multiplication we have to do, then only we can find out the answer 900. But if we apply this process, then easily we don't need to multiply like that. We will find out the answer easily. That is 4 into 25, that is 100, we know that. So 9 into 100 we can write easily 900. So this is the simplest process. So like that we have to find out which one is simpler for us. Clear or not? So in both case, that is the multiplication, and previous we have done addition. So associativity of addition and associativity of multiplication. Both the things we have done. Now I am doing some questions, then only you can identify. So I am writing 14 plus 17 plus 6. So first we can do 14 plus 17 plus 6. So 14 plus 17, that is 31, plus 6, that is 37. And second, this is the step 1, or you can say the first way. Now second way I can apply like that. Same number 14 plus 17 plus 6. If I change the place of the 6, if I write like that 14 plus 6 then 17. So now easily I can identify 14 plus 6 plus 17. 14 plus 6, that means 20, plus 17. So 20 plus 17, that is 37. So I think this is the easy process. In the first case we have to do 14 plus 17, but in the second case we have to do 14 plus 6. 14 plus 6. So that is the easy process. So sometimes we can change the place of the number also. We can change the brackets. Earlier we have done, we can change the brackets like that. First number and second number, and here second number and third number. So we can change the brackets, and now I am doing, we can change brackets side by side, we can change the place also. Clear? So I am taking one more example, that is 12 into 35. So 12 into 35. So 12 we can write 6 into 2. 6 into 2 into 35. Like that also we can do. So 6 into 2 into 35. Now I can change the bracket. 6 into 2 into 35, and now I can give here. Because if we do 2 into 35, then we can do it easily. So 6 into 2 into 35, that means 35 to the 70. So 6 70s are 6 7s are 42, 0. That is our answer. So like that also we can do. And one more thing, that is 8 into 1769 into 125. So as I told you, we can change the place to to do this type of things. So here I have seen 8 and 125. I can do 8 into 125 into 1769. Clear? And we know that 8 into 125, that is 1000 into 1769. So now we can write the answer easily, 1769000. So that is 17,69,000. That is our answer. So in the associativity of addition and multiplication, under this property we have done, we can change the brackets, we can change the place also. Okay, and sometimes we can write the numbers like that also. So now we are going to discuss about distributivity of multiplication over addition. Distributivity of multiplication over addition. Now I am doing some examples that are related. Distributivity of multiplication over addition. So here written 2 into 3 plus 5. That we can write like that, 2 into 3, then plus, then 2 into 5. Right? 2 into 3 plus 2 into 5. So now we can do 2 into 3, 2 3s are 6 plus 5 2 is 10. Now 6 plus 10, that is 16. Clear? I am doing one more example, that is 4 into 5 plus 8. So 4 into 5 plus 4 into 8. So 4 5s are 20 plus 4 8s are 32. So 32 plus 20, that is 52. One more example, that is 6 into 7 plus 9. So 6 into 7 plus 6 into 9. 6 7s are 42 plus 54. 6 9s are 54. So 4 2 6 5 4 9. 96 is our answer. Next, I am doing one more example, that is 7 into 11 plus 9. So 7 into 11 plus 7 into 9. 7 11s are 77 plus 7 9s are 63. So 7 plus 3, that is 0, carry 1. 7 plus 6, 13 plus 1, 140. So that is our answer. So these are some examples related with distributivity of multiplication over addition. Okay. Now you can see here written one question, that is example 5. The school canteen charges rupees 20 for lunch and rupees 4 for milk for each day. How much money do you spend in 5 days on these things? So in our question they have given information rupees 20 for lunch and rupees 4 for milk, right, for each day. That means one day, and we have to find out for 5 days. So we can write easily. So that means 20 and 4 for each day, that means one day. That means we have, for one day, total cost 20 plus 4, that is 24, right? So we have to add them and then we have to multiply them for 5 days, because this one is the cost for one day and we have to find out the cost for 5 days, that means into 5. So simply we can write this calculation like that, 5 into 20 plus 4. So we can see that is exactly look like the example that is related to distributivity of multiplication over addition. Now 5 into 20 plus 5 into 4. So 5 20s are 100 and 5 4s are 20. So our answer is 124. That is the total cost for 5 days. Clear? Now in associativity property, associativity of addition and multiplication. So associativity of multiplication, under the associativity of multiplication I have done 12 into 35 earlier. You have remember that I have done like that. 12, we can write 6 into 2, then 35, and then 6 into 2 into 35. Now we can change the bracket. So 2 into 35, that means 70. So 6 into 70, that means 420. So that is I have done under associativity of multiplication. Now I am doing distributivity of multiplication over addition. Same question, 12 into 35. So how? Now 12 will remain same and 35 we can change. 35 we can write 30 plus 5. So 12 into 30, then plus, then 12 into 5. So 12 3s are 36. So we can write 360, and 12 into 5 we can write 60. So 360 plus 60 we can easily write 420. So same question I have done under associativity of multiplication, and same question I have done distributivity of multiplication over addition. Clear? These are the difference. So I am taking one more example. I have taken one more example, that is written 126 into 55 plus 126 into 45. So if the question is giving like that, then we can do, here you can see 126 is the common number, so we can take this number. So now to this number will vanish, so we will write 55 plus 45 only, because we have taken 126 as a common number. So now we can see 126 into 55 plus 45, and we know that 55 plus 45 is equal to 100. So easily we can write 126 into 100. So 126 into 100, that is 12600. So that is our answer, 12,600. So this is also under the property of distributivity of multiplication over addition. So we have done 4 properties, that is closure property, then next commutative property, commutativity of addition and multiplication, and then we have done associativity of addition and multiplication, and the last thing we have done distributivity of multiplication over addition. Now 2 small things, that is I am discussing identity for addition and multiplication, identity for addition and multiplication. So 2 identities are there. So first thing is that 0. What is this? 0 is called an identity for addition of whole numbers, or additive identity for whole numbers. So what is the additive identity for whole numbers? That is only 0, and one more number, that is 1. So now I am talking about 1. 1 is the identity for multiplication of whole numbers, or we can say multiplicative identity for whole numbers. So what is the multiplicative identity for whole numbers? That is 1. So additive identity 0 and multiplicative identity 1. So here we have done our discussion related properties of whole number.